A farmer has 100 acres of land on which she plans to grow wheat and corn. Each acre of wheat requires 4 hours of labor and $20 of capital, and each acre of corn requires 16 hours of labor and $40 of capital. The farmer has at most 800 hours of labor and $2,400 of capital available. If the profit from an acre of wheat is $80 and from an acre of corn is $100, how many acres of each crop should she plant to maximize her profit? First of all, we need to understand the question and determine the constraints before solving this question and take out all the information given. We can define X as an acre of wheat and Y as an acre of corn. So, here is the piece of information that we can take from the question. As I highlighted in that question, the question asks us to find how many acres from each crop needed to maximize the profit. Therefore, our objective function will be P, which is profit equal to 80x plus 20y, since the question said that $80 of profit for wheat and $20 profit for corn. Next, to solve this linear programming, we are going to list down the constraints. There are 3 constraints in this question, which are acre, labor hour, and capital. So, the 3 constraints that can be listed are x plus y less than or equal to 100, or x plus 16y less than or equal to 800, and 20x plus 40y less than or equal to 2400. Then, we can move to the further step for this linear programming question in Excel. Step 1. List the objective function and constraint function. You can choose any cell that you want to write these functions. So I will choose the C2 cell for x and D2 cell for y. Next, you can list the profit function by putting the input under x and y. So for the profit function, we got 80x and 20y. After that, we can proceed with the constraints function. First, we put the constraint function in the first column, which is an acre, labor hour, and capital. Second, we put the input 1, 4, and 20 for x, and the input 1, 16, and 40 for y. Thirdly, I will put the sign for all these constraint function. The sign of this constraint function is less than or equal to. So to put this sign, you just need to click insert, then find and click the symbols. When you click the symbols button, there are so many symbols that will show up so that you can choose whatever symbol that you want. But in this case, we are going to use less than or equal to symbol. So we just need to find it and click insert, then close. As you can see, the symbol shows up in that cell, and now you can just drag it down. Lastly, you can put the input of the right side constraint in the last column. To make it clear for you, I will put the border for this constraints function by right click and choose borders that will make it look nice and neat. In my opinion, all borders will make it more clear and nice. So that I will just select this border. And now, you are done with the first step and can continue to the next step. Step 2. Find the value of x when y equal to 0 and the value of y when x equal to 0.
I will explain how do we get all this information. First one, for acres, the equation is x plus y equal to 100, which the first step is let x equal to 0 and we will get x equal to 0 and y equal to hundreds. The second step is let y equal to 0 and we will get the coordinate 100 and 0. Let move to the labor hour, which the equation is 4x plus 16y equal to 800. All the working is the same, which is let x equal to 0 and y equal to 0. And we will get the first coordinate is 0 and 50, while the other one is 200 and 0. Last but not least, capital. The equation is 20x plus 40y equal to 2400, and the calculation are the same with others, which will let x and y equal to 0, and we will get 0 and 60 and 120 and 0.
Step 3. Draw the linear programming graph.
First, we have construct the equation, and then we move the data to the table. Acre is constraint 1, labor hour is constraint 2, while capital is constraint 3. So next, we move on to like a graph. So let me teach how to make a graph. First, we highlighted the part that we want, which is constraint 1, acre. And then we go to insert, and then we choose scatter, right with line. So we get this data that have we choose. And then after that, since we don't have any data, we just delete it. And then I will teach you how to edit the data. Click the right, and then here is edit, while this is add the data. You edit series 1. So series 1, my name is C1, which is acre. And then the data that we want for series X is axis X, while for series Y is axis Y. Okay. Okay, now we plus to add for constraint 2. Constraint 2, which is for labor hour. So we choose the data for series X is axis X, while for series Y is axis Y. Okay. And then we add one more constraint, which is constraint number 3. Let's name is capital, and the data for series X is we choose axis X, but for series Y we choose this one. Okay. So yeah, done. So now we can look. So here 0, 20, 40, 50, and here 0, 50, right? And we don't like it. We want to get sent for axis Y and axis X. We can format axis. And then for the measure, we select 20. So yeah, and we can make some validation for our graph as legend. Yeah, done. That's all for me. Thank you.
Step 4. Find the feasibility region.
I will show you how to get the feasible region using this graph. Note that all of these lines are less than the constraint, so it is satisfied here below all these lines. See that the feasible region is the region here. So I'm going to insert. I'm so sorry, I don't know why in this recorded video is not showing the choices, but I will explain to you the step. So after I click insert, I choose shape, then select the text box and label the region. Next, I'm going to shape the feasible region. Click insert, shape, then select the freeform tool. Next, I'll click on one of the corners, move to the second corners, and third until meet to the beginning point to close it off. To make the shape transparent, I right click on the shape and click Format Shape, click Fill, and then increase the transparent as desired. So here I increase the transparent until 50% and choose this color for our graph. So last step, I'll label the corner point with A, B, C, and D.
Step 5. Find the coordinate and maximum value.
I will show how to find the maximum value. First, let's find the coordinate of the extreme points. Point A is the labor hour, so I'll copy and paste it here. Then, I set up cell for X, Y, and Z where the coordinate value will appear. I shade the cell for X and Y, beige, and use blue for Z. After that, I add the coordinate of X and Y. To calculate the value of Z at each point, I use the objective function, which is to maximize 80x plus 100y. So input 80 times x value plus 100 times y value. The corner point 1B is labor hour and capital. So I copy and paste it here. I also set up cell for X, Y and Z and shade it. After that, I'll highlight the two peach colored cell, then type M mark, open bracket, then M inverse, open bracket, then select the coefficients, close bracket, comma, and then select the constraint, and close bracket. Then hold the Ctrl and Shift button, then press enter. After that, I find the Z value by inserting 80 times X value plus 100 times Y value. For corner point 2C, I'm just gonna copy and paste this. Corner point 2C is acre and capital, so I will copy and paste it here. As we can see, the coordinate and Z value is automatically adjusted to 80 and 20. For point D, I'll just copy and paste point A here. Point D is labor hour, so I copy and paste it here. After that, I add the coordinate of X and Y. So we can see that the maximum value of the objective function is 8400 where X equal 80 and Y equal 20.